Hello everyone, my name is Jeffry Gutierrez. We're here to conduct and explain the experiments last Tuesday. It will be the diode identification and half-wave rectifier circuit. So, let's begin. In this video, I'll begin by demonstrating how to identify the terminals of a diode and check whether the diode is functioning properly. This is an essential first step before using the diode in any circuit. Start by identifying the diode and checking whether it's working properly. Using a digital multimeter, I'll first determine which end of a diode is the anode and which is the cathode. By setting the DMM to diode test mode and placing the red probe on one end and the black on the other, a good diode will show a forward voltage drop, typically between 0.6 and 0.7 volts for a silicon diode. When the probes are correctly aligned, reversing the probes should result in no conduction, indicating the correct polarity. This test also helps us check the diode's condition. If it conducts both directions or doesn't conduct at all, the diode is faulty. For the next one, we'll move on to building a simple half-wave rectifier circuit. This basic circuit helps convert AC to DC and is a fundamental concept in electronics. In this part, I'll use a single diode and a resistor to build the rectifier circuit. The AC signal will be supplied using a signal generator set to a 1 kHz frequency with a 5 volts peak-to-peak sine wave. The diode is connected in series with the resistor, and this combination is then connected to the AC source. The purpose of the diode is to allow current to flow only during the positive half cycles of the input AC signal. During the negative half cycles, the diode becomes reverse biased and blocks current flow, preventing voltage from appearing across the resistor. As a result, the output waveform measured across the resistor shows only the positive half of the input sine wave, while the negative half is clipped off. This is the defining characteristic of a half-wave rectifier. And that wraps up our experiment. We've successfully identified the diode terminals, tested its functionality, and built a working half-wave rectifier circuit. By observing the waveform, we saw firsthand how the diode transforms AC into pulsating DC. Understanding this simple yet powerful concept is a great step toward mastering electronics. Thanks for watching!